Hello everyone. Today we are going to see how to convert an Epsilon NFA to a DFA. There are two ways to convert the Epsilon NFA into the DFA. First way is to convert the Epsilon NFA to the equivalent NFA and then convert that NFA to a DFA. But here we are going to see the direct method of converting the Epsilon NFA to a DFA. For that, you will have to know what is the epsilon closure. Now here I am going to assume that you know what the epsilon closure is. So I am just going to write down the epsilon closures of each of the state directly. Epsilon closure of 1 will contain 1 as well as states 2, 4 and 7. Epsilon closure is nothing but set of all states which are reachable from that particular state by using only epsilon transitions. So basically states 1, 2, 4 and 7 are reachable from 1 by using only epsilon transitions. Now for state 2, only 2 would be there in the epsilon closure. For state 3, 3 and 4 would be there in the epsilon closure. Again for 4 it will be 4, 5, 5. For 6 it will be only 6. For 7 it will be only 7, 8 only 8, 9 and 4. So now we have got epsilon closures of each of the state. Now let us see how to convert the epsilon NFA to a DFA. For that purpose we will be starting with a new starting state which is subset of this particular set. 1 is the starting state in the original epsilon NFA. So here what we are going to do, we are going to find out what is the epsilon closure of 1, that is 2, 4 and 7. Now this particular subset would be our starting state for the DFA. Now we have got the starting state. Now we want to find out the transitions for all the inputs. Let us consider the input A. What is the meaning of this is we want to find out what would happen on the input 1, what would happen on the input A if the input state is 1, what would happen on 2, what would happen on 4 and what would happen on 7 if the input is A. So basically we are just finding out the transitions, 1 on A, 2 on A, delta of 4 and A and delta of 7 on A. So 1 on A is 5 because there is no transition. 2 on A is going to state 3. 4 on A there is no transition, that will be 5. 7 on A is going to 8. So now we have got two states, 3 and 8. Now we are just going to write down these two states in our new state, 3 and 8. Now just write down the epsilon closures for these states. So epsilon closure of 3 is nothing but 3, 4 and epsilon closure is of 8 is nothing but 8. So we have got this particular state. This state represents the transition on A. Now we are going to see what will happen if our input is B. Just a second. Okay, so now we are going to see what will happen in the starting or initial state if the input is B. Again, the process will be same. What will happen? Where do we have the transitions for B on each of the states? On 1 there is no transition for B, on 2 no transition for B, on 4 there is one transition for B, 4 is going to 5. But for 7 again there is no transition, so we have got only one transition. And similarly for C, well, none of these states have any transition for input C, so this would basically be a dead state. E, B and C. Okay, so we have just created one dead state. Now consider this particular state 384. The process will be same. For input A, what is going to happen on the input on the states 3 and 8 and 4? So for 3 there is no transition, for 8 there is no transition, and for 4 again there is no transition. So this will again be a dead state. So for input B, 3 there is no transition, 4 is going to 5 and 8 is going to 9. So we have got two states. Now epsilon closure of these two states, epsilon closure of 5 is nothing but 5 and epsilon closure of 9 is nothing but 9. So we have got a new state here. Now for input C, again there are no transitions, so this will again be going to a dead state. So now we have got too many dead states. So well, look at this state 5. In the state 5, for A there is no transition, for B there is no transition. So for A and for B it will just be going to the dead state. Now for C there is one transition, it is going to state 6. Okay, now for state 6 there is no transition for any of the inputs, so for each of the input it will be just going to the dead state. Now state 5, 9, on A there is no transition for state 5 and no transition for state 9, so that is fine. Now for B, no transition for state 5 as well as no transition for state 9, and for C there is one transition, 5 is going to 6, so this will be 8, 5 is going to C. So basically we have covered all the states. Now the question is, what is the final state here? Since 6 is the final state in the original transition graph and 6 is not included in any of the epsilon closures, only here it is. So basically 6 would be our final state, and if we are going to remove all these dead states, let us say, then the diagram would be like this. So basically this is our final DFA, which would contain only 5 states and one final state.